Good evening, guys. I'm back. I hope that you enjoyed your first video. Compliments of Miss Deed and Dosari. And let's go again. This time we're going to talk about the quadratic formula. Last time we talked about completing the square in order to solve a quadratic equation. And this time we're going to use the quadratic formula. The quadratic formula would be used in the event that you had a quadratic equation when you had this case. You had ax squared plus bx plus c. This time you have a coefficient in front of your x squared, your leading term. And in that case, the completing the square method is not very fun to use. You'd have to get that leading coefficient to be 1 in that case. So the quadratic formula can be used in this case. Let's just work through a couple of examples like this. But first, let's talk about what the quadratic formula is. Remember what a quadratic equation is. It's one where you have as your leading term something that has an x squared. All right? And then in standard form means that it has an x squared, an x, and then some constant term. In that case, we're going to call a the coefficient in front of our leading term, our quadratic or our squared coefficient. We're going to call b the coefficient in front of our variable x, and we're going to call c the constant term. In this case, we can come up with the quadratic formula which says you can actually solve this equation right here, this quadratic, for x, using this formula. Negative b, and this b refers to the b up top there, plus or minus the square root of b squared minus 4 times a, and that a is again our leading coefficient there, times c, our constant term, all divided by 2 times a. And again, that a is your leading term. This is called the quadratic formula, and it can be used to solve absolutely any quadratic equation. Please, again, keep in mind, what are you actually doing when you're solving a quadratic equation? You are actually finding where, if anywhere, does a quadratic equation cross your x-axis. And if it does not cross your x-axis, your quadratic equation, your quadratic formula here is going to tell you that. In this case, it might be up here. And in this case, you're going to get imaginary numbers for your x. You're going to get complex numbers. Or what if it was, say, down here in this case? Then you would have imaginary numbers again. But you're going to find out what they are. You'll still be able to get a solution. It's just going to contain an I. Let's work a couple of examples to see what I'm talking about. Here we go. Let's begin with a nice, easy one. Let's start with this one. Here we go. 3x squared plus 2x equals 7. If we were to start with this, we see the 7 is over there by itself. Let's bring it over so that it's in our ax squared plus bx plus c equals 0 form. Ours is not, because the 7 is not over there where it belongs. So let's move it. So we're going to say 3x squared plus 2x. We're going to subtract 7 from both sides so that it looks like our quadratic equation in standard form. And then I'm going to come over here on on the side, and I'm going to say, what is my A term? Well, my A is in front of that x squared, so it is 3. What is my B term? My B is in front of oh, that was not the right thing to do, guys. The B is in front of the plano x, and it is 2, a positive 2. And then we have our C, and our C is equal to a negative 7. Notice that has that negative with it, and we have to, if it has a negative with it, we have to keep that negative. Okay, we're going to keep the negative alongside. If it's a negative here, it has to stay a negative here. All right? We're good? See that? Now we're going to use our quadratic formula, which, remember, says our x, and that refers to this x here, this x in our equation, says we can find out what its value is. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's sub in and see what we get. B is 2, so it's going to be x is going to equal a negative 2 plus or minus the square root of, what is 2 squared? It's 4, minus 4 times a, which is 3, times c, which is negative 7, don't forget that negative, all over 2 times 3. Now we have us an algebra problem, and please remember, guys, to follow your order of operations. Underneath our radical here, we must follow our order of operations. We must do not fall into that trap of doing this subtraction first. We must do our multiplying first. We're going to say negative 4 times 3 is negative 12. Negative 12 times negative 7 is negative 84. Okay, I'm sorry, positive 84. So what we have is 4 plus 84, which is 88. So we have x equals negative 2 plus or minus the square root of 88 all over 6. And you have to see if there's any way that you can reduce that. What you cannot do, and I will not name any names since this is going online, but you know who you are, students. You cannot put that in a calculator. But what you can do is see if you have any perfect squares. And in 88, 4 times 22 is 88. So you do have a perfect square inside there, and that's 4. So I'm going to rewrite that 88 as 4 times 22. Well, what's the square root of 4? 2. So I am going to rewrite this 88 right here. I'm going to rewrite this 88 right here as 4. Oh, that was the wrong pen. As 4 times 22. Yeah? So what we're going to end up with, and I'm kind of writing all over the page here, so I'm going to have to go to a new screen. I'm going to end up with x is equal to negative 2 plus or minus 2, which is the square root of 4, times the square root of 22, all over 6. Now, it would be nice if I could leave it like that, but I cannot, because this is a fraction after all. And what's the very last step always, always, always with fractions? Reduce. And you'll notice we have a 2 here, a 2 here, and 2 goes into 6. And since 2 goes into all of those numbers, I can reduce every single one of these. I can divide by 2. So what we're going to do is end up with x is equal to a negative 1 plus or minus 2, just kidding, 1 square roots of 22 all over 3. And that is reduced in lowest form. And I cannot fix that anymore. I will not fall into the temptation of putting that in a calculator and getting a decimal. Okay, now if I want to get a sense for where this is on a graph so that I can graph it, I'm going to do 2 things. I'm going to go back to the original equation. If you'll remember with me, that original equation was 3x squared plus 2x minus 7. This was my original equation. Since this is a positive 3, I know that my parabola is going to open up. Since this is a negative 7, I know this is going to cross my y-axis at negative 7. So I know those 2 things right away. I can also get a sense for a whereabout this is going to cross my my x-axis simply by saying, well, what is the square root of 22 about? It's somewhere close to 5. And here it's okay to put this in your calculator just for an estimate. I know it's going to be somewhere between 4 and 5 because the square root of 4 squared is 16 and 5 squared is 25. 22 falls in between somewhere, 16 and 25. It falls in that range, closer to 25. So square root of 22 is somewhere between 4 and 5, but closer to 5. Negative 1 plus 5 is a little bit less than 4, yeah? And then negative 1 minus 5 is going to be close to negative 6. So it's going to cross, and I would be okay with you putting that in your calculator so that you can get where this is going to cross, okay? So that you can get a nicer picture of this mess I'm drawing. It's going to cross negative 1 plus a little bit less than 5. It's going to be at a little bit less than 4, which is going to be somewhere in this area. So I'm going to call this negative 1 plus the square root of 22. Oh, I forgot to divide that by 3, guys. I have to back up. So this is going to be negative 1 plus 4 point something something, which is going to be 3 point something something divided by 3. So this is actually going to cross at right about here. And this is going to be negative 1 minus 4 point something something, which is going to be close to 6, somewhere close to 6. Divided by 3 is going to be about negative 2. So it's going to be somewhere close to right here. So our parabola, and it's going to come down here and cross at negative 7. It's going to come something like that. All right? As always, I'm going to give you some to work. I did give you some to work on your assignment page. I will see you in class Thursday.